Hello! Yes, and welcome to our first set of notes for Unit 3. This is Objective 3.1, and Objective 3.1 says I can use the properties of exponents to simplify expressions. So what does it mean to simplify an exponential expression? Well, an expression with exponents is fully simplified when there is only one base of each value and all the exponents are positive. So if we've forgotten, our base, remember, is the large number. The exponent is the raised number, right? And this would be telling us 2 times 2 times 2. The base tells us what we're multiplying. The exponent tells us how many times we're multiplying it. So let's get started with the basic properties here. First, the product of like base powers. A to the m times a to the n equals a to the m plus n. An example here would be if I have x squared times x to the third, all I need to do is say, well, 2 plus 3 is 5, so this would be x to the fifth. Next is the property of like base quotients. A to the m over a to the n is a to the m minus n. So this time, let's say we had x to the fifth divided by x to the third. Well, 5 minus 3 is 2. So this would equal x squared. Then the zero power property. This one's really straightforward. Anything to the zero power is 1. All right? Anything to the zero power is 1. And then an important one, a negative exponent. Let's say I have x to the negative third. I would rewrite this as 1 over x to the third. All right? By switching, remember, because we can't have any negative exponents, we want this negative exponent to become positive. In order to do that, I need to switch where it is in the fraction. Now, let's say we have 1 over x to the negative third. Then this would become x to the positive third, okay? We switch where it is in the fraction. If it's in the numerator, we send it to the denominator. If it's in the denominator, we send it to the numerator. So let's look at some examples of just those properties. So looking at letter A, x squared y to the negative first times x y to the 0 over 3xy squared. The good thing about these is that they can be done in any order. So the first thing I see is I have y to the 0. That becomes 1. So I could rewrite this as x squared y to the negative first times x over 3xy squared. Next, I see y to the negative first. Well, let's move that to the denominator. So x squared times x is in my numerator. My denominator would be 3xy squared now times y to the first. I have a couple operations here where their like bases are being multiplied. Remember, I add the exponents, so that would become then x to the third over 3xy to the third. And then I see here, okay, I have an x in my numerator, x in my denominator. This is x to the first. I would subtract, which would leave me with 2. So my final answer here would be x squared over 3y to the third. Now notice, only positive exponents, only one of each base. That's how I know I'm done. Looking at letter B. So I see right away I have some combinations that can occur in my denominator. I'm going to do that. So 2a to the third b squared over 3 times 2 is 6. 2 plus negative 1 would just be 1. Negative 1 plus 2 would also just be 1. So I'd have 6ab here. Now I see 2 divided by 6, I can simplify that. So this would become, let's see, a to the third b squared over 3ab. And then lastly, I see here a to the third a b squared b. I can subtract from both of these. When I do that, I would have a squared b over 3, right? Because 3 minus 1 is 2. 2 minus 1 is 1. All right, last one. Letter C. Well, I see x to the 0 right away. I see y to the 0 right away. Those are both just 1. And then, so that'll give me 2 over 2x squared y squared. The 2's divide out. So I'd be left with 1 over x squared y squared. And that's all I can do here. 1 over x squared y squared is all I can do. All right. So let's talk about some more properties. Power of a product. A times b in parentheses to the m means it'd be a to the m times b to the m. So let's say I have xy to the third. This would equal x to the third, y to the third. The same applies in fraction, so as a quotient. So x divided by y all to the third, that would equal x to the third divided by y to the third. And then power of a power, this is when we multiply. So let's say I have x squared to the fourth. Well, this would then become 2 times 4 is 8. So it would equal x to the 8th. All right. So now let's try some with those properties involved as well. So the first thing I always like to do is I like to get rid of parentheses. That's what I like to do first. I do see that there's an x to the 0, so I don't need to rewrite that. So I'd have y, x to the third times y over. Now we have power of a power here, so I'm going to multiply. So it'll be x to the 6th, y to the 6th. I can combine my y terms up here, so I'll have x to the third, y squared over x to the 6th, y to the 6th. Now look what happens when I subtract. I'm going to get negative values. I'm going to have x to the negative third and y to the negative fourth. Well, I can't leave my answers with negative exponents, so I need to send both of those to the denominator. So I'll leave with 1 over x to the third, y to the fourth. There we go. There would be our answer there. Now, look at letter B, what happens here. I have y to the 0, I can get rid of that. This entire operation, y squared times x to the third, y to the negative third, is being taken to the 0 power. Anything to the 0 power is 1. So this is just going to become 2x over 1, which indeed equals just 2x. And lastly here for letter C, let's see, 2. So I'm going to start by distributing this exponent up top. So 2 squared m to the fourth into the negative second over 2mn times m to the third n squared. Okay, so let's take care of some things here. 2 squared is 4, so let's write that as 4 m to the fourth into the negative second. Let's combine our terms here in our denominator, so I'd have 2m to the fourth into the third. All right, well, m to the fourth divided by m to the fourth, that can divide out. And 4 divided by 2 is just 2, so I'd have 2 n to the negative second over n to the third. I need to move this negative exponent, right? It needs to go down into my denominator. So I would have 2 over n to the third times n squared. Combine my like terms, so 2 over n to the fifth. And there we go. That's how we can use the properties of exponents to simplify these expressions. If you're feeling confident with this, go ahead and get started on your practice problems. If you want to see a few more examples, go ahead and check out this sample problems video. This is Mr. Carter signing off. I'll see you next time.